All right, so one of the things that makes transition metals super useful is their ability to form coordination compounds. So remember, our transition metals are generally positively charged, and then we can have what are called ligands, right? These are called ligands. And these are just molecules with an extra lone pair that can then be donated to the transition metal. And so the transition metal here, remember, it's accepting an electron pair, so it's acting as a Lewis acid, while the ligand is donating an electron pair, so it is acting as a Lewis base. And so that'll form this complex ion of this, where the metal is now attached to the ligand. So for example, you can have cobalt with 6 NH3s, 6 amines. And in this case, the cobalt has a charge of +3. And so we also have 3 chlorides kind of floating around. Remember, everything has to be nice and charge balanced. So this is what's known as our kind of complex ion here, or coordination compound. And then these are basically just counter ions to balance out the charge. So if you were to think about what this molecule would actually look like, you'd have a cobalt 3+ in the center, and then 6 amines in this octahedral shape. And that's your actual kind of complex ion. And then you have 3 chlorides just kind of floating around in this outer sphere just to charge balance. Notice that the charge of the transition metal doesn't really relate to the number of things attached to it. So it's a bit different there. And one of the main things you'll see with transition metals is that they always just kind of do their own thing. So here's just an example of different ligands you can have. So you can see water can be a ligand, ammonia, NH3 already covered that. The halides can be ligands, and then other molecules can be ligands. You'll notice they'll all have some kind of lone pair to donate, because you need to be able to donate a lone pair to act as a ligand, to act as a Lewis base.